Okay, take a seat. So, good afternoon, everybody. So, let me tell you what I did so far. I explained addressing modes, okay? And last time, last quiz was about addressing modes, okay? And as you notice, in every lecture, I'm using addressing modes, right? In every for every instruction. Also, I explain data transfer instruction. How can you copy register to register, immediate value to register, memory to memory, and so on. Is that okay? And tomorrow we're gonna have a quiz on data transfer instructions. Is that okay? And also, I almost finished arithmetic instructions. Okay, I told you what instructions we have here for arithmetic. Yeah, I told you for arithmetic, I explained addition, subtraction, increment, decrement, complement, one's complement, two's complement, clear and set for flags, and you can clear also registers and memory locations. Also, we have multiplication and division. I didn't finish multiplication and division last time, so I'm going to finish them today. Tomorrow, we're going to have a lab. This lab is on arithmetic instruction. Also, we're going to have a second quiz on arithmetic instruction. So tomorrow, we're going to have two quizzes, guys. One quiz about arithmetic instruction, the other one about data transfer instruction. Okay. So again, these quizzes, I'm going to test you. I just want to make sure you understand the instruction. When I say transfer A, B, you understand what this means. Okay, so very, very simple. But okay, so now, so for multiplications, what we have, what I explained last time for multiplications, as you see here, guys. Oh. Okay. So as I explained last time, guys, for multiplication, we have only 3 instructions for multiplication. As you see here, we have instruction mul, M-U-L. This instruction actually multiplies register A to register B and to store the result in a word in register D. So this instruction is going to multiply or multiplies a byte by a byte and to store the result in a word. And this multiplication is unsigned. These numbers are unsigned. This is the first one we have. We have 2 more instructions, guys. These 2 emal and emal s. You see s here, okay? This s means it is signed, by the way. So we added this s because this one for signed, this one for unsigned. Both of them are doing the same thing. Both of them are gonna multiply a word by a word and to store the result in double word. What do you mean by double word? 32-bit. 32-bit, okay? So at this 32-bit, 16 here and 16 here, 32 bits. Is that okay? So here I can say, if you want to multiply word by a word, so you can use one of these, okay? Signed or unsigned, okay? However, if you want to multiply byte by byte, and this multiplication is unsigned, yeah, you can just use this one. What if I want to multiply byte by a byte, but this multiplication is signed? Very simple. Do we have this instruction? No, we don't. So what can we do? Very simple. If you want to multiply byte by a byte, sign, so actually you have to use this one, and you have to multiply word by word. So what you have to do is, you have to extend this byte to a word. You have to extend this byte to a word and then do the multiplication. You got what I'm saying? Simply because we don't have this instruction. Here also, I'm telling you here is give does it matter signed or unsigned here? The answer yes, it matters because the result is different. Signed or unsigned are going to give us different results. That's why we have 2 different instructions for signed or unsigned. Okay, I'm giving you a numerical example here. If I want to multiply this binary number by this binary number, if these numbers are unsigned, so actually you want to multiply 255 by 3 which should be the result should be 700 something, right? In binary. If they are signed, so the result should be -3. This one is different from this one in binary. That's why if you wanna multiply these two numbers, should we get this one or this one? Is that okay? That's why we don't have only one instruction. We have two instructions for signed and unsigned. Okay, and I made it very clear in the very beginning of this course that signed or unsigned, there is something you are the programmer. You have to decide in the very beginning. When you write your code, you have to decide what numbers are signed, what numbers are unsigned, and if they are signed, you have to use signed instructions. Okay, if they are unsigned, you have to use unsigned instructions. Is that okay? Sometimes it doesn't matter. For example, in data transfer, I didn't tell you we have data transfer for signed or data transfer for unsigned, simply because it doesn't matter. In data transfer, you just copy bits. It doesn't matter if signed or unsigned. Is that okay? For addition and subtraction also doesn't matter, right? Because you just add bit to bit, so it doesn't matter. One plus one is 0, so it doesn't matter. Okay. After I finish this section, I'm gonna start a comparison. When you compare, okay, if A is greater than B, conditions here it matters. That is why you will see again similar to what I did here. You will see we have an instruction for signed, we have an instruction for unsigned. Okay. Anyway. Also, I started to explain last time for division. For division, you can divide 16-bit by 16-bit, and the result you are gonna get the result in quotient and the remainder. Each one of them should be stored in 16-bit. Okay. So what instruction we have here to divide 16 by 16, guys? We have idif, as you see here. We have also idif s. So we have two instructions here. You can also tell from the here similar to what we did before. This S means signed. So we have two instructions here, guys. This one for unsigned, this one for signed. Both of them are going to divide 16-bit by 16-bit. The quotient is going to be stored in 16-bit. Remainder is stored in 16-bit. Okay. So this instruction, guys, always, you don't have a choice. Always they divide register D by register X. Okay. And then they are going to store the quotient in X and the remainder in D. Is that okay? Very simple. Okay. So the other, any question here before I move to here? Forget this one now because I'm going to explain it shortly. So forget it for now. Okay. The other option you have, you can divide 32 bits by 16 bits. Okay. And the quotient is 16-bit and the remainder also is 16 bits. Okay. We have two instructions here, guys. We have edif and edif s, as you see here. You can tell again, this s for signed. So this is for unsigned, this is for signed. So how both of them are doing the same thing, but this is signed and this is unsigned. Both of them actually, they are going to divide 32 bits, which are register D and Y, where D or register D is the least significant word, Y is the most significant word. You divide it by X. The quotient is going to be in Y, remainder is going to be in D. Is that okay? So if you notice here you divide Y and D. If you go back here, you see multiplication Y and D as well. You see how they are compatible. Why they are compatible this way? Because maybe after you do multiplication, you want to divide. You got what I'm saying? So they made it compatible. So after here you multiply, the result is going to be Y and D. So now if you want to divide the result of the multiplication, you can just use this one, Y and D. Okay, guys? Any question? Very, very easy. So for division, we have only 4 instructions, as you see here. One for 16-bit by 16 bits, the other 32 bits by 16 bits. In both cases, the result you are going to get in quotient and the remainder. Every one of them is 16-bit, as you see here. Okay. Last time I explained also what I mean by quotient and remainder. As I told you, for example, if I have 10, if you divide 10 by 3, okay, that means quotient means how many groups I can create of 3 from 10. That's what I did. This is one group, one group, one group. The remainder, how many numbers here that are less than a group. So that's why we call it the remainder. So they are not enough to be in a group. You got what I'm saying? So if we do this case, guys, as you see here, so I have number 10. So this is one group, okay? And we have only one is the remainder here. So in this case, I'm going to say the quotient is 3. That means I have 3 groups of 3, okay? And the remainder is 1. Is that okay, guys? If the remainder is 0, that means this, how can you know if this number is divisible by 3 or not? I think we are going to do something like that later. You understand what I'm saying? If a number is divisible by 3, how can, or if I ask you, can you check if the number is divisible by 7? Okay. What you have to do, you can just divide by 7 and then look at the quotient. If the quotient is 0, yes, it is divisible by 7. Same thing if you want to see if the number is even or odd. I'm going to divide it by 2. If the remainder is 0, so this number is divisible by 2. It's even. Yes. Question? Yeah.
We would just check the remainder.
Yes. Because if it is divisible, there is no remainder. Okay. If you have a number, if you have even number like number A, if you divide it by 2, so that means there is no remainder, right? If it is divisible by 2, the quotient is going to be 4, the remainder is 0. So later, yes, if you want to test if this number is divisible by 7 or whatever, you can just look at the remainder. Yes. So say it again.
How do we do division of floating point numbers? For example, dividing 9 by 2 with 4.5.
We have one more instruction to do division for fractions, okay, or decimal point numbers. However, I'm not putting here in the lecture because I don't think we're going to need, but there is one instruction to do that. Okay, so there is one more instruction to do division for decimal numbers. Okay. So for now, guys, so what I want to say, guys, now let's look at very important thing because you are going to have it tomorrow in the lab. You know, tomorrow's lab you are going to do it's a practice on arithmetic instructions. And we are going to practice also on multiplication and division. There is a trick in tomorrow's lab. Okay, I'm going to tell you what is the trick. But let me ask you a question here. Can overflow happen here? Ever happen here? Can overflow ever happen here? Keep in mind, when I divide by 3, so I can guarantee that the remainder here is less than 3. Is that right? Remainder has to be less than 3. Because if it is more than 3, I would put it in the quotient, right? So the remainder here has to be less than this one. Is that okay? So let me ask you a question. So now, can overflow ever happen here or happen here? See the answer. The answer is here. No, overflow cannot happen here. You know why? I'm going to tell you why. Because I'm going to divide 16-bit by 16-bit. When you divide, the result should be smaller. You got what I'm saying? The quotient and the remainder should be smaller. You got what I'm saying? Because you divide. You got what I'm saying? So if already the number here and number here are already enough to be in 16 bits, that means the quotient and the remainder 16 bits should be more than enough. Got what I'm saying? So let me say it in a different way. So the quotient you have to get here, guys. The quotient has to be less than this number. It has to be less. Unless there is a 1 here, less or equal. So always this one less than or equal. That's why if this one is already in 16-bit and this one 16 bits, okay, so I guarantee there is no overflow. I'm not gonna need more than this space. Same thing here for this one, for remainder. Remainder always has to be less than this one. So if I put this one in 16 bits, okay, and I put the result in 16 bits, there is no way that this one will be greater than this one. You got what I'm saying? That is why in this case, guys, there is no overflow cannot happen here because I have enough space. What about this one? Because this is a problem you are going to have tomorrow's lab. What about this one? Here, no overflow can happen. Why overflow can happen? Because you have a very large number here, 32-bit number, right? If you have a very large number, 32-bit number, I divide it by 16-bit. It is possible, it may happen that the quotient needs more than 16 bits. You got what I'm saying? So you have 32-bit number, I'm going to divide by 16. If the 16-bit number is very small, like I'm going to divide it by 2, by 3, I'm going to divide by a small number, okay? Maybe it's going to happen that the quotient, I need more than 16. That's why overflow can happen here. Is that okay? Remainder, it's not going to have any overflow because usually for the remainder, I'm going to get less than this number. If this number is already in 16, this one 16, that's okay. The problem may happen here is the quotient. You got what I'm saying? And how this is going to work, and this is the problem you are going to have tomorrow in tomorrow's lab. In tomorrow's lab, I shouldn't tell you. I should leave you to just think about it. So, but in tomorrow's lab, what's going to happen is that I give you numbers. You should, before you come to the lab, you have to calculate the expected results. You have to calculate what you are expecting, okay, for the results. And then you have to run the program and see if you are going to get the expected results or not, okay? In one part of tomorrow's lab, no, you are not going to get the expected results. Actually, you are not going to see any change here in Y or G or X, because I told you here I'm gonna put the result in Y. I'm gonna put here the result in G. So what's gonna happen, because there is an overflow, you are gonna see after division, Y and G are storing the initial values before division. So usually, if you don't understand, if you don't know the reason, you will think that the instruction is not working. You are going to go to the TA, look the TA, you are going to tell the TA, look, I did division, but actually the result, I didn't get the result. So this instruction is not working. You got what I'm saying? No, the instruction is working, but what happened is that because there is overflow, so these two values are not going to be updated, are not going to change. Okay. Anyway, observe for this tomorrow. You understand what I'm saying? Any questions? Should I say it again? What I'm saying, if there is an overflow, number one, you should understand overflow can happen here. It cannot happen here by common sense. It can happen here because 16-bit may not be enough to store the quotient. Why? Because this is a big number, 32 bits. Okay, and that's what's going to happen tomorrow. Okay, so overflow can happen. This is number one. Number two, if overflow happens, what's going to happen here? These values are not going to be updated, are not going to change. Okay. So they are not going to change because there is overflow. It's not because the instruction is not working. Okay. So anyway, any questions? Okay. Let's have an example. It's just a very simple example. So all what you have to do, guys, again, as you see here, every instruction I explain for multiplication or division, it has to be done by registers, as you see here. Okay. So what if I want to multiply memory location to memory location? What I can do? Do you have an instruction to multiply memory location to memory location? Answer is no, we don't have. But you can do it. Oh, yeah, very simple. All what I have to do, I'm going to read one memory location, put in A. I'm going to read the other memory location, put in B. Do the multiplication. Now you have the result in D. You can store it back to memory location. You get what I'm saying? Same thing for division. So always the number you want to multiply, just to put it in the register, do the multiplication, and then store the result back. That's what we're going to do right now. Okay. So let's see the first example here. In the first example, I want the word at location 1000. I want to multiply it by the word at location 1002. So here I'm very specific. I'm telling you I want to multiply word by word. And I told you this is unsigned multiplication. And then you have to store the result. The result is 4 bytes. You have to store it in these four memory locations. Is that okay? So very simple. Look at we don't have many instructions. Look at the instruction we have. So I want to multiply word by word unsigned. So very, very easy. So this one should be okay, right? Because this is unsigned and you can multiply word by word. So I can use this one. Is that okay? That's what I'm going to do right now. So what I'm going to do right now, guys, I'm going to copy the first word here, copy the second word here. I'm going to do the multiplication, and then I'm going to store this result in memory. Is that okay? Let's see. So as you see here, guys, here, I'm going to read the first word. I'm going to put it in register D. I'm going to read the second word. I'm going to put it in register Y. So the two words I want to multiply, one word I'm going to put it in T, the other one I'm going to put it in Y. Okay, why D and Y? Because this is how the instruction works. I don't have a choice. This is how it is, right? Then I'm going to do emal. I'm going to write emal. Okay, emal, this is for unsigned. Okay. Once you do emal is going to multiply Y by D and then store the result Y and D this way. So now you have the result in Y and D, right? Now I want you to store the result in these locations. So all what you have to do, guys, usually this may be a little bit tricky. Usually when we store the most significant first and then the least significant. We're going to do the same thing right now. So what we're going to do right now, I'm going to store the most significant first in the first, and then I'm going to store the least significant. So that means register Y has to come here, register D has to come here, and that's what I did. Store Y, store D. Is that okay, guys? Any questions? Easy, right? Okay. Let's see next one. Next one here. I want to divide the word at location 1020 by the word at the location 1005. So I want to divide word by word, and then this division is signed. This division is signed. Is that okay? I want to divide word by word, and it is signed. Number one, you have to ask yourself what instruction I can use. So here I want to divide word by word here, and it is signed. So I have to use this one, right? It is signed. So I have to use IDIFS. And in case of IDIFS, so you have to put here one in G, one in X. Okay. Yeah. So here I'm going to use IDIFS because you want to divide word by word. Okay. And they are signed. And this one can do that. Okay. All what I have to do, guys, as you see here, I have to read the word. This word, I have to do it. I put it in register D. I have to read this word. I put it in register X. And then I'm going to do division. Once you do division, the quotient are going to be in X. The remainder is going to be in G. And then I asked you to store. I asked you to store the quotient in these two memory locations and to store the remainder in these two memory locations. Is that okay? So let's see how can we do this in instruction. Number one, guys, I have to read the word at 1020, put it in G. That's what I did. Very easy, right? Number two, I have to read the word at 1005, put it in register X. Yeah, that's what I did. Very easy, right? Now one number in register D, the other one is in register X. Now I can do division. That's what I did. I did division here. Is that okay? After I do division, so now the quotient is in X, the remainder is in G, right? So I'm asking you to store the quotient in this memory location and the remainder in this memory location. That's what I did. So I'm going to say store X, store D. Okay, guys, very easy, very straightforward. Any questions? Anyway, tomorrow also we're going to have a lab. We're going to have a quiz on also in arithmetic instructions. Okay, any question, guys? Are you okay? Now, tomorrow, 2. It was supposed, one quiz was supposed last time, but I just because I know in this course, in my opinion, the most difficult two topics, in my opinion, is the addressing modes. Really difficult to understand it at the very beginning, or you may get confused easily in addressing mode. Is this a memory or is this not a memory? Is this address or you mean this is a content? You got what I'm saying? So this is a difficult part in my opinion. The second part is what I'm going to explain right now. You making conditions. I think these two parts are the most difficult. That's why I preferred last time to have only one quiz about addressing modes. Okay, but these two quizzes should be easy because just I'm gonna if you already understand addressing modes, so I'm gonna so the exam the quiz will be about your understanding to the instructions, which is easy. You get what I'm saying? Because you should now understand the addressing modes, right? Anyway. Okay, so now I'm gonna move to the next section here, guys, about branches and loop instruction. Again, this section is very, very, very important. We're gonna use it all the time. Very, very, very important. Little bit tricky. So that's why, in my opinion, maybe this is the last difficult part in the whole course. I guess I hope so. Okay, everything is should be. But anyway, nothing is difficult, but it needs just to understand it very well. So I will do my best here. So here I'm gonna explain branch and loop instructions. Okay.
Did Gordon win every fight in this bracket by submission? He did. All right. Yeah. I think if he can submit everyone, that up, man, that'd be shot can make it tighter. When you don't fulfill the takedown, it makes it tighter. Yeah, you just carry.
Okay, anyway. Okay, guys, so let's start this part here. Okay, so what I want to explain, guys, in this section, I'm going to explain how can we make loops. You should understand what loops from C language, right? In C language, you did for loops, you did while loops. How can we do same thing in assembly? That's what I'm going to explain in this section. Also, how can we do branches? What do you mean by branches? I mean something like if statement, something like if, look here, guys, we want to do, this is not assembly, but I want to do something like that. If A is greater than 5, so you have to go to here, else come to here. That's why it's like a branch. There is a branch. So once I come here, I can come this way if the condition is false, or I'm gonna go there if the condition is true. That's why you call it a branch, because you created a branch, either this way or that way. Is that okay? So that means when I come here, this is a condition. I need to check this condition, either go this way or that way. That's what I call branch instruction, okay, like if statement. So I'm going to teach you how can we do something like that in assembly. Loops, you know what I mean by loops. Loops means it's some code or some instructions I want to repeat. I want to read multiple times, like for loops. You want to repeat it, right? That's what I'm going to explain now. So I'm going to start with branch instruction. Let's first classify. I'm going to make a classification now for the branch instructions. For the branch instruction, I'm going to teach. By the way, before I continue, I already give you in chapter 1. I give you some idea about how can we do this condition in assembly. I'm gonna build, or you are gonna understand it better. But I already give you some idea in chapter 1. If you remember, in chapter 1 when I told you, if I want to do something like if A is equal to 2, then go to a location, for example, called next. Any name. So go to a certain location. I'm gonna call it next. Okay. In assembly, we don't have this statement in assembly. We don't have something like that in assembly. Okay. Because remember, we're gonna do it by the hardware. Okay. So the way the hardware is going to do it, as I explained in chapter 1, I have to use two instructions. Remember, the first instruction I have to do subtraction. So I have to subtract 2. I have to subtract 2 from A. I have to do subtraction. Subtraction, yes, because when you do subtraction, you are gonna update the flags. So number 1, I have to do subtraction to update the flags. Okay. And then after that, you have to use a branch instruction. This branch instruction is gonna branch or not based on the value of the flags. Let me give you a specific example. Look here, guys. In this case, if it is equal, so if they are equal, so after subtraction, the 0 flag has to be 1. Does that make sense? So when I do subtraction, the 0 flag has to be 1. Okay. So we have a branch instruction. This instruction is gonna branch if the 0 flag is 1. You know what I'm saying? So this one, we have an instruction called branch if equal. I'm gonna explain it later. This instruction is gonna branch if the 0 flag is equal to 1. So this one is gonna only look at the 0 flags, not gonna look to any other flags. You got what I'm saying? So this is the basic idea we're going to use right now. Okay. Also, we have something for greater than or equal, less than or equal, and so on. In this case, maybe the branch instruction needs to check more than 1 flag. Okay, but it's the same idea. Okay, guys. So this is exactly how we are going to make condition right now. Number 1, you have to do subtraction. I'm doing subtraction not because I'm interested in the difference. No, I'm not interested in the difference. I'm doing subtraction to update the flags. Because based on the values of the flag, so I did subtraction to do comparison, like you compare. Because based on the value of the flag, I can know if this number is equal or not, if this number is greater, if this number is less, based on the values of the flags. You got what I'm saying? So conclusion, as you will see right now, guys, if I want to do a condition like this one, we're gonna use 2 instructions next to each other. One instruction is gonna do subtraction to update the flags. Next one, branch instruction, and this branch instruction is gonna check the flags, right? And we have different branch instruction. We have one branch if equal. So this one is gonna branch if the zero flag is 1. Okay. If we had branch if not equal, this one is gonna branch if the zero flag is 0, because that means the two numbers are not equal. We have branch if greater. We have branch if less or equal, or less or lower, as I'm gonna explain later. Okay. Again, all the branch instructions are gonna take the decision to branch or not based on the values of the flags. Conclusion number 1: to do condition like this condition in assembly. Number 1, you have to compare, you have to subtract or do comparison. After that, you have to use one of the branch instruction. That this branch instruction should check the flags. So I have to set the flags first. Okay. Anyway. So for this kind of branch instruction, I'm going to do classification for the branch instruction I'm going to explain now. We have some branch instructions, we call it conditional and unconditional classification. Okay. So some of the branch instruction, I'm going to call them conditional. Some of them are unconditional. You can tell from the English name. This one is condition. The branch is conditional, or the branch is not conditional. You can tell from the English name. But anyway, I'm gonna. Some branches are long, some branches are short. Some branches for signed, some branches for unsigned. This is a classification. Let me give you the details. Number 1, the first classification, we have conditional or unconditional. You can tell from the English name. Conditional, for conditional, these conditional branches, they are gonna branch if the condition is true. So we have a condition. If the condition is true, it's gonna branch. If the condition is false, it's not gonna branch. Very simple. You got what I'm saying? Okay. So for example, something like that. If A is greater than 2, okay. If the condition is true, it's gonna branch. If the condition is false, it's not gonna branch. So here in this case, in case of conditional branches, so we have instructions for conditional branches, we have an instruction for unconditional branches. In case of conditional branches, okay, so the branch can be taken or may not be taken. Okay, you can branch or not. You may not branch. Okay, it depends on the condition. The condition is true, the branch is taken. The condition is false, the branch is not taken. Is that okay? You can tell from the English name conditional. The other one is unconditional. Unconditional branch. Again, you can tell from the English name unconditional. That means I will branch no matter what. There is no condition to check. I will branch no matter what. Is that okay? Some students are a little bit okay. So if this one you are gonna branch no matter what. So what that means I'm not gonna execute this part of the code because you are gonna branch no matter what. Yeah, sometimes we need something like that. How? I'm gonna give you. It's too early, but I'm gonna just because many students asked me before. If this is unconditional, so that means why I have to write code here if I'm gonna okay. Why I have to write here code so if you are gonna branch anyway, so I'm gonna skip this part anyway. So why you have to write code here? Okay, I'm gonna tell you. I'm gonna give you one example here. For example, guys, you know if else statement. Okay, if A is greater than 2, so I want to execute this part. If not, else execute this part. Okay, this is if else. Body of if, body of else. Okay. So what happens is that if the condition is true, I'm gonna come here this way. Is that okay? And because I executed this part, always I have to skip here. Always, no matter what. You got what I'm saying? So you will see it right now. But anyway, this is just one case. If I execute this part, I should not execute this part, right? Because this is like if else statement. So if the condition is true, I have to come here. If I don't write an instruction here, you are going to continue. If you don't write an instruction, it's going to continue. That's why I have to write an instruction skip. This is different. I know some students may be confused. This is different from C language. In C language, you have if, and then you have you may put braces here, and then you put else, and then you put braces, and then automatically once you execute this one, so it's gonna go outside. It's not gonna come to this part. Okay. In assembly, in order to do something like that, you have to write instruction. Yeah, I have to write an instruction. If you execute this part, so you have to skip this part. That's exactly we're gonna do it using unconditional. So once this part is true, I'm gonna execute this part. So here I'm gonna write unconditional branch this way. Anyway, so don't worry, we're gonna do it right now. So don't worry about it. Now, all what I want to do right now, I just want to do classification. So when I teach branch instruction, I'm going to tell you this instruction conditional or unconditional. You should understand if it is unconditional, what it means. If it is conditional, what it means. Very simple. In case of condition means the branch may be taken or may not be taken based on a condition. Condition is true, taken. Condition is false, it's not taken. Is that right? Unconditional, the branch is taken no matter what, regardless of anything. Also, there is no condition, right? Unconditional. Anyway, any questions? Okay. Also, some instruction I'm going to teach, I'm going to tell you this instruction is long and this branch instruction is short. I want, yes? No, no. In case of equal, if I want to check equal, I'm only interested in the zero flag. I'm not interested in other flags. But if you want to look for greater, you're going to look for other flags. If you want to look for less, you know what I'm saying? Yeah. So when you do subtraction, I'm going to update all the flags. And then, this is a very good point. So you're going to do subtraction, I'm going to update all the flags. And then, after that, you are going to use branch instruction. The branch instruction is going to look at 1 flag, 2 flags, 3 flags, based on the instruction. In case of branch of equal, this one is going to only look at the 0 flag. But if you say branch of greater, it's going to look at other flags. Okay, guys? Again, this all this done by the hardware, by the way. This is how we jump by the hardware. This is how we implement if by the hardware, right? So when you do subtraction by the hardware, flags are updated automatically by the hardware, right? And branch instruction is going to update BC to do branch. It's going to update BC, okay? If the 0 flag is 1, if it's branch of equal, right? So it's gonna do like logic circuit. If based on the instruction, in case of branch of equal, okay. So this one is gonna look at the 0 flag. If the 0 flag is 1, so this instruction is gonna put the target address wherever you wanna go. It's gonna put it in BC so that you can branch. You understand what I'm saying? Anyway, I'm going to say it again. Maybe I said it before, but let me, you know how the hardware is going to do branch? I explained it before, but I can explain it again. How branch is done by the hardware, I'm going to tell you. Look here, guys. We have an instruction here, and then I'm going to say here branch to next. Next in any name, just any name, okay? This is an instruction, branch. Branch, you have to go. Next here, you have to put the name here. Is that okay, guys? So what happens here, when I come here, it has to branch to here. How the hardware is going to do that? I'm going to tell you how the hardware do it. Very, very simple. When we execute this instruction, PC should be here. Okay, so PC should equal, for example, 4020. For example, so PC is here. Is that okay? As I told you before, every time you write a name, even if it is a label, the code word is going to replace it by address. So what happens here is that this you are going to write next, but code warrior is going to replace next by the address. What address here? For example, 7,000. If the address here is 7,000, so that means 7,000 is here. Code warrior is going to do that. Is that okay? So here we are saying I want to branch it to next, but code warrior is going to say branch it to the location 7,000. Is that okay? So what this instruction is going to do, guys, in order to branch, it's going to say BC should equal 7,000. That's it. So that next time I'm going to execute from here. We're going to execute from here next time. And instead of this one going to be this one. Is that okay? So you have to load BC with the target address where you want to go. Again, you are not going to do that by yourself. I'm saying how the instruction works, how this kind of branch is done by the hardware. Is that okay? Any questions? Anyway, let's come to the definition. When I tell you this instruction is long or this instruction is short, what it means? I'm going to tell you what it means. If this instruction is short, okay, look here, guys. This is the branch instruction is here. I want to branch it to next. Okay, maybe if next is here, so I have to jump from here to here. Does that make sense? Or if branch is here, so I have to jump from here to here. Is that okay? Target address. So if I'm here, so I have to go there or have to go there. Okay, so there is a target address if you jump. Okay. The question is there a limit? Is there a limit? How much how much bytes you can jump or not. If there is a limit, that's what we call short instruction. So in case of short instruction, guys, in case of short instruction, if you are here, maximum you can go back negative 128 bytes. So this is the distance from here to here. It should not be more than 128 bytes. In case of short, if I'm here, okay. In case if you are gonna move forward, the maximum is 127 bytes. In case of short. So in short instructions, there is a limit on the jump. Limit on the jump. In case if you want to jump backward, you should not jump more than 128. If you want to jump forward, you should not jump more than 127. Is that okay? There is a limit. It's a short. If you try to jump more than that, code error is going to give you error. It's going to tell you something like branch is out of range. Okay, so you are out of range. Okay, this is if it is a short branch. Okay, so short branch means there is a limit on how big you can jump. There is a limit, right? This limit is 128 or 127 in case of forward. This is in case of backward. Is that okay? In case of long, there is no limit. You can jump anywhere in case of long. You got what I'm saying? So when I teach instruction, guys, I'm going to tell you this is long, this is short. Is that okay? Long, there is no limit. You can jump anywhere. Short, there is a limit. If you jump more than the limit, you are going to receive error here, branches out. Okay? Okay. So look here. For most of the instruction we have, as you will see right now, we have two versions of every instruction, one short, one long. Can I use long all the time? Because for peace of mind, I can just use long because long there is no limit. I can branch anywhere. You got what I'm saying? Short is there is a limit. So for most of the instruction I'm going to teach, I'm going to tell you there are two versions, one long, one short, one long for most. But for very few instructions, the only short. We don't have long version of it, okay? But most of the instruction we have two versions, long and short. So the question is, can I use long all the time for peace of mind? Just because I don't know how big I'm gonna jump, can I use long all the time? The answer is yes. For this course, that's okay. You can use long all the time. However, you should understand, okay, if this is the case, if I can use long all the time, so why is he invented short? Why is he made short? I'm gonna tell you why. Simply look here, guys. The idea is very simple. Short is efficient, much more efficient than long. I told you before, efficient means it takes less memory space, it takes less time, right? You know why? That's why if you care about efficiency, it's better to use short than long, okay? If you can. Sometimes if you want to make a big jump, so you don't have choice, okay? So you have to use long anyway, right? But if you have the choice and you care about efficiency, you should use short and long. I'm going to tell you why. You know why? I'm going to tell you why. The reason is, if you are here, in case of long, for example, when I say branch next, so next here is going to be replaced by the target address, for example, 7,000. Okay, so that's why this instruction, when it is stored in memory, is going to be long instruction. This one is going to be long. Why? Because I have to store the target address as a part of the machine code. So when this one is converted to machine code, so what's going to happen? 7,000 should be a part of the instruction. So the machine code is going to be long because you have to store the target address. This is in case of long, right? Not only store, you have to read it as well. So I have to read two words as well, right? Anyway, however, short is using the idea of offset. Offset. If PC is here, add 20. Or sorry, subtract 20 or add 20. So I'm not going to store address. I'm going to store the offset, right? And this offset is a byte. So what happens here, in case of short, the idea is different. So in case of short, if I wanna go next, what I'm going to say here, guys, from here to here should be plus 20. So here I'm going to say plus 20, right? Instead of the whole address, the shift. So how this branch is going to be taken, BC should equal BC plus 20. Come to here. You got what I'm saying? That is why if you look at the number I explained right now, negative 128 and positive 127, this is the number for 1 byte. You remember when I explained before, what number I can store in 1 byte? Because this offset, I'm going to store it in 1 byte. So here's the offset here, which is, this offset is going to be a byte. And as I told you before, in a byte, I can store from negative 128 to positive 127. Anyway, if you didn't understand it well, that's okay. But I'm going to tell you the conclusion now. The conclusion now, guys, is number 1. For most of the branch instruction I'm going to teach, we have 2 versions of each instruction. One is long and the other version is short. Okay. Short is used, short has a limit on the jump. Long, there is no limit. Okay. That's why short is more efficient. Okay. In this course, maybe efficiency is not big deal. Can I use long all the time for peace of mind? The answer is yes. You can use long for the good thing. If you make a mistake, this is not a logical error. So this is the code error can catch this error. I'm going to give you a message, something like that. Branch is out of range. So if you see something, a message like this branch is out of range. So you need to know that this is a short, but you want to jump too much. Okay, it's a short. So yes, when it is possible for peace of mind, you can use long all the time, but still you should learn. Maybe you need it in the future. Short is more efficient in case you care about efficiency is a big deal for you. Okay. So yes, when it is possible, you can use long all the time. However, we have a very few instructions. They only short. They are short. They don't come with long version. Okay. But most of the instruction, they come with long and short version. Okay, guys. Any questions? The last classification I want to make, and this is the easy one. So now I want to classify, guys. What I'm doing right now, I'm classifying the different branch instruction. I'm going to explain. For every instruction, I'm going to explain. I'm going to tell you if this one is conditional or unconditional, right? I already explained what this means. This one long or short. I already explained what this means. Okay, long or short. Now I'm going to move to this one, and this is the easy one. For every instruction I'm going to teach, I'm going to tell you if this is signed or unsigned. Signed or unsigned, guys, it means this is similar to what I explained before. Do you consider this number signed or unsigned? Is that okay? So if your number is unsigned, you have to use unsigned branches. If your numbers are signed, you have to use signed branches. Does it matter if it is? Does it matter if it is signed or unsigned? The answer is yes, it matters. Give me examples. This is the example you have right now. If register A is storing 1111, as you see here, okay? Now I want to do comparison. So I want to compare this one with number 2. Should I jump or not? So the condition is true or false. Okay, look here, guys. If your number is unsigned, so actually register A is storing -1. And -1 is not greater than 2. So the branch should not be taken. However, if your number is unsigned, so A is storing 255, and 255 is greater than 2. So the branch has to be taken. You got what I'm saying? That's why it matters. It matters. That's why we have 2 different types of branches, signed or unsigned, because it depends on if the number is signed or unsigned. Is that okay, guys? Okay. So now I'm gonna start. I'm gonna start to give you branch instructions. So for every instruction, I have to tell you if the instruction is conditional or unconditional. I have to tell you if it is long and short, if it is signed or unsigned. Now you should understand when I tell you this instruction is conditional, what it means. This instruction is unconditional, what it means. Long, short, okay? Signed or unsigned, what it means. Any questions here before I move forward? Okay. Okay, so let's explain the instructions we have here. Number 1, unconditional instructions. We have only one instruction for unconditional. Easy. For unconditional, we have only one. Okay, this one is called BRA branch. BRA. So you have to say BRA, and then you have to say label. You have to put a label here, a name. Okay. So in a name, if you put a name here, that means I want to branch to this location. Okay. And we have only one instruction. And this instruction actually comes with 2 versions. One version, as you see here, without letter L, and this version with letter L. So as you see here, guys, we have two instructions, one without L, one with L. The difference between them, the one with L is long, the one without L is short. So this is short, this is long. That's all what we have. Very easy. So conclusion, for unconditional instructions, we are going to have two. One is called BRA and the other one long BRA. So this is short, this is long, and this is unconditional. Then you have to put a name here, a label, and this label you have to write it in your program. So you have to next to an instruction, you have to write this label. Okay, this is where you have to jump. Any question? Okay. Now I want to move to conditional instructions. Conditional instruction. In case of conditional instruction, guys, as I told you, we have to use two instructions, as I told you. Number one, you have to update this one. You don't need to update the flags here. You don't need to update the flags here, right? Makes sense? Because this one is going to jump no matter what. There is no condition, right? So here, this one is not going to check the flags. So this one jump anyway, right? However, here, if you want to use conditional instructions, number one, you have to do, as I told you, you have to do subtraction to update the flags. Is that okay? This number one. Number two, after you update the flags, you have to use one of the branch instructions. For example, let me give you an example. If I want to do something like this one in assembly, C language, I want to do something logic like this one in assembly. If A is equal to 2, go to next. Okay, I want to do something like that. Look how I can do it. I'm going to compare A to number 3. Okay, so here, what is compare? You told us subtraction. So what happened here, guys, look here. This is subtraction. So here, if I use subtraction instruction is gonna subtract, store the result in A, update the flags. So subtraction instruction, number one, do subtraction, update the flags, store the result. Now I'm not interested in the difference. I don't know. I don't care about the difference. I just want to compare. I want to do subtraction just to update the flags. I don't want to store the result anywhere. That is why they made a new instruction, and this instruction is called compare instruction. Compare instruction. So what is the difference between compare and subtraction? Let me write it here. So if you use subtraction and compare instruction. Okay, so this one is gonna subtract. This one also is gonna subtract. This one is gonna update flags. This one also is gonna update flags. Okay, the difference is here. This one is gonna store the result in a register or somewhere. This one ignores the result. Ignore the difference, the result. Ignore it. So it's not gonna be stored anywhere. You get what I'm saying? So again, subtraction and comparison are doing everything except only one thing. Here, the difference is going to be stored. Compare, the difference is not stored, which makes sense because here I'm not doing subtraction because I'm interested in the difference. I'm just doing subtraction because I just want to update the flags. So this one should be okay. You got what I'm saying? So here, that's why if I want to do a logic like this one, guys, look how I made it. I'm gonna compare A to number 2. Is that okay? Compare A to 2. So compare A to 2. This one is what this one is gonna do. Is gonna subtract 2 from A. Okay, it's gonna subtract 2 from A. It's gonna update the flags, and then this one is not gonna change A. It's not gonna store the result anywhere. Only update the flag. After this one, so the purpose of this instruction is just to update flags, right? After this one, I'm going to use one of the conditional branch instruction. For example, if I'm interested in equal, so I'm going to use branch if equal. So this one is going to branch if equal. Equal means the zero flag is 1. If A is equal to 2. So if A is equal to 2, this subtraction is going to put 1 in the zero flag. This one is going to branch if the zero flag is 1. Okay, guys? So that's how we're going to do it all the time. Number one, you have to use compare to compare A to a number, for example, or a memory location, as you will see later. Okay. Then you have to use of the conditional branch instruction. This is branch if equal. So these two instructions together, guys, these two instructions together, that means I want to branch to next if A is equal to 2. Is that okay? We have different instruction. We have greater, we have less, we have less or equal, or greater or equal. So we have all of them. So now if you are interested in equal, you can just use equal. Okay, guys? So now I want to teach what compare instructions we have. So conclusion. If you want to create a condition, in assembly, number one, you have to use compare instruction to update the flags. This number one. Number two, you have to use one of the branch instruction. It means what you want to do. So we have branch instruction for equal. Okay. So if the condition is equal, you have to use branch if equal. If your condition is not equal, so you have to use a branch if not equal. If it is greater, you have to use branch if greater. If it is less, we have branch for less, and so on. Is that okay? So this is how we create condition. So to create condition, you have to use two instructions. Compare, after compare, branch, as you can see. So number one, what instruction we have for compare? Now, you know what compare is doing, as I explained. We just is going to do subtraction, update the flags, and that's it. It's not gonna change any registers. It's not gonna store the result anyway. So let's see what instruction we have for compare. The instruction we have compare, as you see here, guys, compare A and B, CBA. So this one actually is gonna subtract B from A. Is that okay? Subtract B from A, or compare A to B. Okay. We have also compare A to memory location or immediate value. Okay. So this one is gonna subtract memory location or immediate value from A. Compare B. So this one, same thing. This one is gonna subtract B from immediate value or memory location. So this instruction for bytes. This instruction for words. Okay. So this one here, compare D. So here, any memory, again, I made it very clear. So if I say 1000 here, so this one, I'm gonna compare B, or I'm gonna subtract this byte. So this is a byte from B, a byte. However, all of the coming ones here are for words. So if you say here 1000, so this is a word. It's gonna compare D to a word. You can compare D, you can compare X, you can compare Y, immediate value, or you can compare S, stack pointer. Okay, guys, any questions? Very easy. So for compare, we have only this instructions for bytes, and we have this instruction for words. As usual, you don't see here, I cannot compare memory location to memory location, as usual, right? But that doesn't mean I can't do it. No, you can do it. All what you have to do, guys, is you can read one memory location, put it in A, and then you can compare to the other memory location. So if you want to compare memory location to memory location, or if you want to compare memory location to immediate value, we don't have this instruction. We don't have an instruction for memory to memory or memory to immediate, but still you can do it. All what you have to do, you are going to read a memory location, put it in A, and then here you put the memory or immediate value. Is that okay, guys? As you will see right now. Any question about compare here? That's all what we have. Anyway, if you go to here, I summarize. If you go to the chapter here, I summarize all the instructions here. So if you go. Yeah. So compare instructions are here, guys. Okay. Compare instructions. We have something we call it test instructions. Test instructions. So how they are different from compare? Okay, I'm going to tell you how they are very close. I'm going to tell you how. Okay, so here Hmm. Okay. Okay, guys. So, okay. So now I already explained compare instructions. This compare instruction, you are going to subtract register from register, like this case, or you can subtract immediate value, or memory location from a register, like all these cases. These for bytes, these for words. Okay. We have also a test instruction. How they are different, or how are they similar to compare? Yes, they are similar to compare. However, test instruction always are going to compare to zero. Always. For example, we have only 3 instructions of them. Look here, guys. We have TSTA. So this is called test A. So this actually like compare if equal to 0. That's it. Okay, you got what I'm saying? So this instruction is similar to this instruction. You compare to 0. Again, if you love this one or you like this one, are okay. So test instruction is similar to compare, but it's only used if you want to compare to number 0. That you can't put any other number. Is that okay? So if you want to say test A, this one similar to this one, compare B to 0. Same thing, we have test B. This one is similar to this one, compare B to 0. Is that okay? This one is similar to this one. Maybe this one is not very attractive because I have alternative here. Maybe this one is not very attractive because I have alternative here. This one may be attractive. This one, very interesting. You know why? Because here you are going to test a memory location. So this one, you are going to, when I say, for example, test 1000. So this actually, you are going to compare 1000 to 0, right? We don't have, and if I want to do this one using compare, I have to write 2 instructions. I have to read this one first to A and then compare A to 0. That's why this one is attractive. Because if you want to replace this one with compare, you have to write two instructions. Okay. So conclusion, test instruction is similar to compare instruction, but this one you are going to compare only to 0, like test A, test B. So this one compare A to 0, compare B to 0, or okay, subtract 0. But if you say test and memory location, this is a byte, not word. It can be used for a word, byte. For example, if I say test 1000, so you're going to subtract 0 from 1000, or you can use compare this one. Okay. But here you have to, in case of compare, because I can't compare memory location to 0 directly. I don't have this instruction, right? So I have to read 1000 first and then compare it to 0. I have to write 2 instructions. Any questions? Okay, so that's all what we have. So again, if you want to build a condition, first you have to put compare or you have to put test instruction. After that, you have to use one of the conditional branch instructions. Okay. Now I'm gonna teach the conditional branch instructions we have. I'm gonna classify them into. So these are the conditional branch instructions. I'm gonna classify them into simple branches, right? These branches are going to branch if only one flag is 0 or 1, as you will see right now. So so we call them simple branches. because these ones are going to I'm going to branch if I'm going to look at one flag, 0 jump or 1 jump. Okay, as you will see now, so that's why they are simple. We have another branches. These branches like greater or equal, less or less or equal. Okay, so let's start with this one, simple. So for the simple, that's all what we have. Look here, guys. Branch, B means branch. L means long. L means long here. L here means long. As you will see right now, guys, every instruction, we have 2 versions of every instruction. One without letter L. So this is a short version. And another one with letter L, long version. Is that okay? So for every instruction I'm going to teach right now, we have 2 versions. One that starts with letter L. So this is long. Without L, it is short. Okay. Anyway, so let's see. So this instruction, look here, B means branch. If carry is clear. So this instruction, is gonna branch if the carry flag is one, is clear, is 0, right? This number 1. Number 2, branch if carry is set. So this one is gonna branch if the carry is 1, is set. Okay, look at this one. Branch if equal. Branch if equal means branch if the 0 flag is 1. So this one is gonna branch if the 0 flag is 1. This one, branch if not equal. So this one is gonna branch if the 0 flag is 0. Is that okay? What else do you have? I have two more instructions for V flag. I have 2 more instructions for N flag. So now in total we have 4 flags, or 4 flags: 0 flag, carry flag, V flag, N flag. For each one of them, we have 2 instructions for each one of them. One branch of 0, branch of 1. Is that okay? So we have here branch if the V flag is clear, branch if the V flag is set. Okay, branch if minus, minus means the negative flag is 1. Branch if plus, PL. So this one is gonna branch if the negative flag is 0. Okay, guys. So now I explained 8 branches. Okay, every flag has 2 branches. One is gonna branch if the flag is 0. The other one is gonna branch if the flag is 1. Is that okay? As you see. And all of them we call them simple. We call them simple branches, right? And for every one of them we have 2 versions: one without letter L and one with letter L. So these are short. If you add L, you make it long. Okay. So let me see here in the table. Yeah. Again, I summarize them in the table here. Let me see. Yeah, in the table here. Okay. Look here, guys, in this table. So these are what we call simple branches. That's what we call simple branches. So, okay. So as you see here, guys, for every one of them, we have 2 versions. As you see here, one without letter L and another version with letter L, as you see here. So without L, with L, with L and without L. Okay. So these are short and these are long. Is that okay? So let's see how it works. This one branch if carry is clear. So if the carry is 0, branch. Branch if the carry is set. Okay. Branch if equal. Equal means the 0 flag is 1, right? Branch if minus. So minus means the negative flag is 1. Branch if not equal. That means the 0 flag is 0. Branch if plus. That means the negative flag is 0. Branch if the V flag, the overflow flag is 0, or branch if it is 1. Any questions? So after compare, so you have to use compare or test. Okay, I told you compare and test are very close to each other. And then after you update the flags, then you have to use one of these instructions. Any questions? Okay, so the last instructions I'm gonna teach these ones here. After that, we're gonna have a lot of examples. So here, let me go back here. Look here, guys. I told you the conditional branches. I'm gonna classify or divide the conditional branches into simple branches, or if you want to do something like that, greater or equal, less than or equal. Is that okay? So now, right now, I'm gonna teach you 4 instructions. 4 instructions. One for greater or equal, less and less or equal. Is that okay? And for each one of them, we have long and short. So now the 4 becomes 8. You got what I'm saying? So I need 4 instructions. One for greater or equal, less and equal. Is that okay? For each one of them, there are 2 versions, long and short. Not only that, for each one of them, we have 2 types, signed or unsigned. Signed or unsigned. You got what I'm saying? So total 16. But again, 16, 8 and 8. So here we need 4. I need 4 for signed and 4 for unsigned. If you number signed or unsigned, we have 4 and 4. Is that okay? And every 4, there is another 4 for long. Just you add letter L at the beginning. That's it. Okay. So let's see what we have here. Look here, guys. We have here greater, greater or equal, less, less than or equal. Is that okay? Your number can be signed or unsigned. In case of signed, we use the English words just to differentiate with between signed and unsigned. In case of signed, use the English words greater, less, equal. Okay, this is in case of signed. In case of unsigned, we use equivalent but different English words like higher, like lower, like same. You get what I'm saying? So, for example, so as you'll see right now, so here greater means higher. Greater means higher, right? However, we are going to use the word greater, less, equal for signed numbers. If for signed branches, we are going to use higher, lower, or same for unsigned. Is that okay? So let's see. For example, look at this very nice example. Look here, guys. I'm going to compare E to 2. Compare E to 2. Then I'm going to use this instruction. Branch if greater or equal. What it means? G means greater, E means equal. That means I'm going to branch if A is greater than or equal to, as you see here. So if I use this two instructions together, that means I want to branch if A is greater than or equal to. Is that okay? However, you have to use this one no matter what. So I have to use this one. If I use this one here, this one branch if greater than, branch if greater than. So if A is greater than 2, I want to branch. Okay. This one here, branch if less or equal, less or equal. Is that okay? This one less than. That's it. So this is the 4 we have. So I have greater or equal, greater than, less or equal, less than. Is that okay? For sure, you can remove letter L or put letter L. So these are low. That's it. Is that okay? In case of unsigned number, I'm going to do exactly the same thing, but I'm going to use different English names. So I'm going to use H for higher. Instead of using G here for greater, here I'm going to use H for higher. Here I'm going to use L and L, right? But here I'm going to use S. Here I'm going to use E for equal. So let's see how it works. So look here, guys. Again, you have to compare first. After that, you have to say branch if higher or same. Higher or same. So if A is greater than or equal, if higher or equal to 2, so the branch should be taken. Is that okay? This one, branch if higher. This one, branch if higher, only greater. Okay, higher. This one, branch of lower or same. Branch of lower. You can see here, guys, they are different in instruction. Yes, they are doing exactly the same thing. Okay, but this is signed and this is unsigned. Any questions? Okay, so let's have examples. I think the best way to understand this part is by examples. In all the example, we are going to do the following, guys. Number 1, I'm going to use compare or test instruction to update the flags. This is number 1. We're going to use compare or test instruction to update the flags. This is number 1. Number 2, after that, you have to use one of the branch instructions. Okay, for branch instruction as a let's go to the table. The table actually summarizes everything I just explained. Look here, guys. Yeah, so these are compare instructions. This is test instruction, and this all here for unconditional. For unconditional, we have only one here. Unconditional. For conditional, all of these are conditional here. All of these are conditional. Conditional instruction, all of them. For the conditional, I'm going to divide it into simple, or unsigned, or signed. Okay. For simple here, you are going to check only flag. So you have an instruction, you can jump if any flag 0 or 1, right? So we have here, this one is going to jump if the carry is 0, jump if the carry is 1, jump if, and so on. So all flags, okay? And then here, these instructions here, these ones are going to use if you want to make a relation, something like greater, less, greater than or equal, less than or equal. If you want to do something like that, you have to use one of these. Okay. Here, the only difference, as you see here, guys, we're again with branch if high or same. So when I use the word high or use the word same or use the word lower, so that means it is signed. In case of signed, we use the G for greater, less, L for less, and so on, and E for equal, right? So here, branch of lower, less, right? Branch of lower or same. We have here branch of greater or equal, branch of greater, branch of lower or equal, branch of lower than. Is that okay? You can see here, guys. For sure, this is outside the scope of this work. These details outside of the scope of this course. But if you want to know if it is higher in case of unsigned, so this is the condition it has to check. So if the C or the zero flag is equal to 0, that means this condition is true. So you can see here for all of them. This is how can we test how the hardware is going to know if it's greater or equal, less or less than equal, in case of signed or unsigned. But the details, because some of them have like a proof and something like that. But just I want to convince you how everything is working. Number one, you have to update the flags, and then you have to use one of these branches. These branches are going to just look at the flags, as you see here. It's going to check the flags. Based on the value of the flags, the branch will be taken or not. Okay, and that's how can we build the conditions. So that's what I'm gonna continue next time. So next time, yeah, today I know I taught a lot of instructions. That's true, but starting from next lecture, I'm gonna give you a lot of examples so that you can understand better how can we use these instructions. Okay, guys, thanks so much.